Good evening, students. Today we are going to discuss one question based on the Henry's law. You know about the Henry's law? That will, I think, you will learn that in your solution lesson. So, for gas in liquid solution, Henry's law will be applicable. If you want to dissolve some gas in a liquid, then you should maintain the partial pressure properly. There is the partial pressure of the gas outside the liquid surface only determine how much gas should be dissolved in a liquid. That is called Henry's law. So partial pressure of the gas is directly proportional to the mole fraction of the gas. The proportionality constant will be the Henry's constant. This is actually the Henry's law. So here you may think like that, ma'am, Henry's law has been given. That is KH has been given. What is KH? 1.4 into 10 to the power minus 3. And then they have given the partial pressure of the gas also. And they have mentioned this is oxygen gas. And they have mentioned the volume also. Then it is easy to determine how much gas oxygen will be dissolved in the liquid if you are having the partial pressure 0.5 like that you can think, but look at the unit of this Henry's constant. Usually, in our Henry's constant formula, we are having one Henry's constant will be equal to partial pressure of the gas divided by mole fraction of the gas in liquid. So, what is this actually? Partial pressure of the gas in mole fraction of the liquid. That is, mole fraction is not at all having any unit, but partial pressure is having only atmosphere unit or some other bar pressure unit. But here, look at this, they are having molarity per atmosphere. They didn't give the Henry's constant in terms of atmosphere unit. They have given some other unit. So we have to modify that Henry's law. Let us do this one. So while you are looking that, it will be very easy, but while you are doing that, it will be somewhat complicated. You have to apply something. That is, you have to think intellectually to solve this question. Shall we solve this one? Get ready with me. And I'm going to write the Henry's law again. Partial pressure of the gas will be equal to the Henry's constant and the mole fraction of the gas in a particular liquid or particular solvent. Here they have given, they didn't talk about that solvent, but anyway, they have given some 100 ml volume alone. But here my problem is the KH unit will be 1.4 into 10 to the power minus 3 mole per liter per atmosphere. So what is the meaning for that? Some constant in molarity per pressure they have given. So the pressure we are going to use here is partial pressure of the gas. So molarity per atmosphere only they have given in terms of Henry's that is instead of Henry's constant they have given molarity per pressure of the, that is partial pressure of the gas. So we have to modify this formula in terms of molarity and the partial pressure of the gas. Shall we do that? Look at this. Here Xg will be number of moles of gas divided by total number of moles of gas. Instead of taking total number of moles of gas, I am going to take only the liquid solvent moles alone, because the liquid solvent moles will be very high compared to Ng. So the total number of moles, that is NL plus Ng, will be approximately NL. So that's why I'm going to, that is number of moles of the particular solvent, that is liquid solvent. So I'm going to take like this. So number of moles of the gas can be written like that. That is, the molarity will be equal to number of moles divided by volume of the solution in liter. So how can I write the number of moles of that? There is number of moles of the gas. That is, number of moles of gas in terms of molarity will be, that is, number of moles of gas will be equal to molarity into volume of the solution in liter. So in terms of molarity, I'm having something. So I'm going to write that one. Ready? So here, in partial pressure, that is KH in terms of mole fraction, that is mole fraction in terms of molarity will be written like that. Molarity into volume divided by number of moles of liquid solvent. Look at this here. Molarity, that is, instead of Ng, molarity into volume divided by NL. So that is what I have substituted here. And one more thing, so KH, so real KH for ourselves, that is, this formula suits for real KH. That is, our real KH will be, what is that? Our real KH will be partial pressure of the gas. That is, our real KH will be X G, sorry, I'm sorry, it's not xg, it's partial pressure of the gas divided by partial pressure of the gas divided by mole fraction of the gas. This is our Henry's constant. That is what we have derived the Henry's constant as partial pressure of the gas divided by mole fraction of that gas. Here the molarity into volume divided by number of moles of liter. So that is a liquid solvent. And then here I'm going to get that is we are having only m by g, that is kh in terms of m molarity by partial pressure of the gas, right? So I'm going to take that molarity and partial pressure of the gas alone. I'm going to take here. So molarity, and if I'm rearranging that one, partial pressure of the gas, that is this partial pressure of the gas will come here. And then what are the other things? Xg will be taken here, and then m by pg, I have taken this side. Already one partial pressure of the gas is there, and then volume of the solution and the number of moles of the liquid. Everything is given here. And then look at this. Here, instead of writing xg, I can write number of moles of gas divided by number of moles of liquid. That is liquid solvent. So molarity by pressure Pg. Here we have, that is they have given us 1.4 into 10 to the power minus 3, because this is actually the Henry's constant they have maintained, molarity per partial pressure of the gas. 1.4 into 10 to the power minus 3. In the partial pressure they have given 0.5, and the volume in 100 ml they have given. So in liter you have to convert, and then NL is there. Liquid, number of liquid, moles of liquid, number of moles of liquid, left hand side, right hand side cancelled. So number of moles of the gas will be equal to 1.4 into 10 to the power minus 3 into zero point 0.5 into zero point 0.1. Actually, when you are doing that one, you will get that is 70, I think, right? So okay, 70. So totally how many units are there? Three units are, three digits are there. So 0.070 into 10 to the power minus 3 is the number of moles of gas that has been dissolved. So they are asking the weight of the gas dissolved. So given weight divided by molecular weight of the oxygen will be 32. Here they have used the gas oxygen. So 0.070 into 10 to the power minus 3. So W will be equal to, that is given, that is weight of the oxygen that has been dissolved will be 0.07 into 32 into 10 to the power minus 3. Let us work out this one. So 14. Okay, so this one will be 2.24 into 10 to the power minus 3. That is approximately, that is actually equal to 2.24 milligram. Hope you have understood that question. Students, while you are looking at this one, you may have a lot of doubts. To clear that one, you should not see the video completely. You have to try with your own way again and again, and then you have to solve your doubts by seeing the video. Without doing that one, when you are seeing the video itself, you may get the right conclusion, like that. Yes, this question is very easy. Yeah, we can do like that. Like that, you may think, but when you are doing, you may get some confusion. Your confusion will be cleared by seeing the video again and again. Thank you, students.